Going to show you how to solve every single problem on a real previously administered math level 2 test. My name is Royce and I actually have my own math YouTube channel, but I work for a tutoring company called Helm Tutors, and they asked me to make a solution video for this math level 2 test, so here it is. Over the years, I've worked with about 200 students 101, tutoring them on the math level 2, and about 70% of my students have gone on to get 800s. So whether that's your goal or something else, I hope you find this video very helpful. With that said, since I do want to show you exactly what I would do in every question, we're going to go through this more efficiently than, say, like if I were tutoring you 101 on a particular topic. Yeah? Okay, and I'll be using the TI-89, so that's what I'll do every demonstration with. Alright, here is the TI-89. Yeah? Okay, cool. And I think you can see it enough, so let's get started. Alright, so this is the first page of this real test, and now that I'm wearing gloves, like peeling the pages might be like the hardest part. And here are some more instructions and directions if you like care for them, but let's dive right into the problems, right? So the first problem right here, number 1, is asking us the fifth root of 4 minus 3x is equal to 2. What is the value of x is the question. So what I would do here is, to start, raise both sides of this equation to the fifth power. And when I do, on the left side, I'd have the fifth root of stuff to the fifth power. So the fifth root and the fifth power cancel, and I'll just have 4 minus 3x equals 3 to the fifth, which is 243. And if you don't know that, you could just use your calculator. Next, I'm going to subtract 4 from both sides of this equation. And so doing that, we see that we could write negative 3x is equal to, what's that? 243 minus 4 is 239. And then you could divide both sides by negative 3, right? So divide by negative 3, divide by negative 3. So x is equal to 239 divided by negative 3, which I guess you could do in your calculator, right? Okay, so that would look like this. So 239, well, let me raise it up so you can see everything. So 239 divided by, and the negative for numbers is right here. The minus sign is right there. So negative, and then what was it? Negative 3. So, okay, negative 3, and then I hit diamond, enter, and that's because I'm set in exact mode. So when I hit diamond, enter, it gives me an approximated answer with decimals instead of like a number like 239 over negative 3. Yeah? Okay, or a fraction I meant. Okay, you get it. Okay, so that's the answer, and that is one of the answer choices, specifically B. So here we are. Now, this is not what I would do if I was doing this on the real test. What I would do is I would type the equation after I select F2 solve, and solve it using the calculator. So this is literally what I would do if I was you and taking this test for real. So I would do this. And we don't have fifth power unless we write 1 over 5. And remember, 1 over 5 as an exponent is like fifth root. And so so we have this equals 3, right? And this is what we're trying to solve. So comma x, and then hit enter. And again, I hit diamond enter for the same reason. You see, that was so much quicker. So that's what I would have done if I was doing this on the real test. Okay, let's go to problem 2. So it says f of a equals, well, you know how to read. So which of the following is equal to f of 4, 8? So first let's figure out what f of 4, 8 would be. F of 4, 8 would be equal to 4 plus 8 divided by 2. Now note that means that the numerator is 12 and the denominator is 2. We know 12 over 2 is 6, but I'll leave it like this because you see this 2 here is the same as that 2, which we can do nothing about. And therefore what we have to do is ensure that the sum of a and b is 12. Well, if you look through this list, the only place where the sum of a and b is 12 is E, so there that is. Alright, so that completes problem 1 and 2. So problem 3. So problem 3, by definition, 6 factorial is 6 times 5 times all the way to 1, right? So therefore, we can write 6 factorial is 6 times 5 factorial. Because, as I said, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. But then this says 6 times 5 factorial, which is 5 times. You get it. Okay, and then divided by 3 factorial times 5 factorial, wherein it's pretty clear that we can cancel this 5 factorial and that 5 factorial. So we get 6 divided by 3 factorial is 3 times 2 times 1, which is 6. So 6 over 6, which is 1. And therefore, the correct answer is D. Now, in 4, it says the graph of which of the following has a slope of 1/2. Not this. This is a horizontal line. Not this. The slope is 2. Not this. The slope is again 2. Not that. The slope is 1. This here, the last answer choice, we can write as y equals 1/2 x to make it abundantly clear that the slope is in fact 1/2. Instead of x over 2, you can write 1/2 x, but clearly the correct answer is E, and there we are. Now, number 5. Number 5, I'm going to teach you a calculator trick that will save us. But yeah, it says that g is f of x, and it asks you for g of 1.7. So g of 1.7, first notice, would say is equal to f of 1.7. But then you'd have to plug in 1.7 into f, take the answer, and then plug it back into f, right? Like, so this will be some number, f of 1.7. So once you figure it out, you gotta then plug that into f. You gotta plug in f of 1.7 into f here. All right, that's all like a lot of kind of plugging in, especially with an inconvenient number like 1.7. If it was like 9, then fine, because square root of 9 would come out cleanly as a 3. But square root of 1.7, okay, so this is what we're gonna do. What we're gonna do, and this is a clever trick on the TI-89 calculator. So what we're gonna do is we're gonna go to y equals, and I've already typed f in there. Okay, so we have f saved under y1, notice. So we can come to our home screen and first write y1 open parenthesis of 1.7. This is literally telling the calculator to go to where we wrote a function under y1 and evaluate that function at 1.7. How awesome. So we go, what's the answer to this? And that's that. And now this number here, 3.0 blah blah blah, is f of 1.7. So what we need to do now is plug f of 1.7 into f. So we need to evaluate f at this number. Oh, nice. I know what to do. We're going to come here and we're going to copy this number, and then we're going to come over here and we're going to delete 1.7 in here and paste our number in there. Paste it and then hit enter. And now we've evaluated f at f of 1.7, and therefore our final answer is what's displayed in the calculator. So 4.737. So what's that? Where is that? 4.7 is the best answer, right? Okay, cool. Let's keep it moving. So what's next? Like I said, peeling these pages is going to be the most difficult task. 6. Okay. 6 gives us like a weird fraction, like, right? It's a fraction divided by a fraction, but fine, like we could still look at it as like a single fraction by seeing this here as 1 minus 1 over m as the numerator, and then 1 over m as the denominator. Now we know that we can multiply any fraction by 1, so then we can multiply this fraction numerator and denominator by m. That way we've multiplied by m over m and therefore multiplied by 1. Now when we multiply the numerator by m, we're going to have m times 1, which is going to be m, and then minus m times 1 over m. M times 1 over m is just going to be 1, right? Okay, so we have m minus 1, the numerator, and then the denominator we have m times 1 over m, which is just going to be 1, so our final answer is m minus 1. So the correct answer is B, and we can keep it moving, but I just want to give you another option if like you didn't understand what I just did. And that other option is this, which is you could just like work here in the numerator with 1 minus 1 over m and get it to be like a single fraction, and then you already have that in the denominator, so you can do the keep, flip, change, or whatever. So here's what I'm saying. 1 minus 1 over m can be written as m over m minus 1 over m. And so you'll have this over 1 over m. And now this here is m minus 1 over m. And so you have that divided by 1 over m. Now, so you have a fraction divided by another fraction, which is the same as the first fraction, which is m minus 1 over m, times the reciprocal of the bottom fraction, right? So this is the keep, flip, change that I was talking about that a lot of students like. So you do that, and then once you do this, look at what you could do. Obviously, this m and this m cancel, and you've got m minus 1 again. So that's that. Now, here is the next problem, right? The next problem is 7, and it gives us a line in slope-intercept form, and it says this line has points in the first quadrant if and only if. So let's draw us a quick coordinate axes. So like this will do, right? Like something like this, right? Okay, so here it is. And so it says like, so you've got a y-intercept of -1, so the line is like, has a y-intercept of -1. And then the slope is clearly b, right? And it says it has to have points in the first quadrant. Well, notice that b cannot be 0, because if it is, then we'd have a horizontal line, right? If b is 0 at just -1, and then we'll never enter the first quadrant, which is like right here, right? The first quadrant. Okay, we'll never enter it if we just have a flat line. But anything better than a flat line, any tilted line, will eventually enter the first quadrant. So we need b to be greater than 0. And other than that, like, you know, we need b to be less than infinity, because notice that a vertical line going through here would overlap with the y-axis. But any positive slope will have us eventually enter the first quadrant, right? So we just need b to be greater than 0. Correct answer, E. I can explain this a little bit more, but I think that's sufficient explanation. All right, next is we're given that tan x is equal to 5, and we're asked to find the quotient of tan x and cot x. Remember, cot x is equal to 1 over tan x, and therefore cot x in this case is 1 over 5, because we're told tan x is 5. So tan x over cot x is going to be, since tan x is 5 and cot x, as we just saw, is 1 over 5, is going to be 5 divided by 1 over 5, which is the same as 5 times 5 over 1. This is the keep, flip, change stuff again, and here is 25. Yeah? Okay, cool. So that's that, and so we keep it moving, and that was 8, so next is 9. Okay, 9. All right, so what do we have in 9? At 9, we're given this quotient here, and we're asked to solve for w. And notice that we're told f times g times e, or e times f times g. Whatever, I read it out of order. But anyway, we're told that this is not equal to 0. The only reason we are told that is to tell us that none of them are 0, and therefore we can divide by any of them. All right, cool. Nice side note. But otherwise, we are trying to isolate w, and we want w equals. All right, first let's get w in the numerator, and we do that by multiplying both sides of the given expression by this denominator here. So when we do on the left side, we'll just be left with a plus bc, and then on the right side, we'll have g times, I'll write w in black so we can keep track of it better. So w, and then e plus f, right? Okay, cool. Next, I could write a plus bc on the left and distribute this g, because until we do that, we really can't work on isolating the w. So we got g, and then w, right, and then e, right, plus fg. Now we subtract fg from both sides of this equation, and we have a plus bc minus fg is equal to g we, right? Okay, cool. And then next, it's pretty obvious what we have to do to get w by itself, which is divide both sides by ge. And when we do, notice on the right side, we just have w by itself. And then on the left side, we have answer choice A. Yeah? Okay, cool. Now, next is 10. And 10 is if the probability of a certain event occurring is 4/9. So P of A is equal to 4/9. What is the probability of the event not occurring? So what is P of A complement? 1 minus 4/9, and therefore 5/9, right? And that's because we know in general that P of A complement is equal to 1 minus P of A, right? Okay, cool. All right, so 5/9, where's that at? Right here. Okay, the next problem, it says that x has to be 0 or positive, but otherwise it's asking us to solve this. Yeah? Okay, I did promise I'm just going to show you how to efficiently solve these. So here, what I would do is just type this equation exactly as is, into my calculator and let the calculator do the job. So that's F2, and then solve, and then it's x to the fourth minus 19 equals 19 comma x. We're solving for x. We have to tell it comma x. That's a syntax. There, we've got two numbers, and it says we want the positive one, the one greater or equal to 0. So that's 2.4. What is that? 48? Yeah, so 2.48. How nice. That was quickly done and efficiently done. Well done, calculator. And I would do that every single time. Okay, so next is 12. 12 says if theta is 38 in this visual, so theta is 38, and like I said, this is a previously administered real test, so some students went to the SAT and took this like a while back. Anyway, theta equals 38, and what's the value of t? I don't know. I've got the opposite side in the hypotenuse, so maybe sine of 38 will help us figure it out. So sine of 38 will equal t over 4, from which it's pretty clear that t has got to be equal to 4 times sine of 38. Now, very important to make sure that you are in degree mode versus radian mode, and all the mode changes happen right here. So right now, I want to make sure that I am in degree mode. Are we in degree mode? Yes, that says degree. So we're good to go. From the home screen, we want 4 times sine of what? Sine of 38. So 38. There we go. And that's 2.46. And that's an answer choice. There we are. Okay, now here it says Joe has a test average of 87. Well, okay, fine. You can read. We know that his final is, his overall grade is calculated by 70% of his test average and 30% of his final exam. And we want him to have 90 as his overall grade. So what we want is 90, right? And we get there by taking 70%, so 0.7 of his test average, so 70% of 87, and then plus 30%, so 0.3 of this unknown quantity, which is his final exam, right? All right, so his final exam is x. We just have to solve this simple linear equation. How am I going to do it? You guessed it, F2 solve. So 90 equals, what is it? 0.7 times 87 plus 0.3x, and then comma x. That's what we're solving for. Hit enter. And what does that give me? That gives me, I'll scoop my calculator up next time so you can see every button I'm pressing, but that gives me x equals 97. Nice. So there we are. Okay, now next it says that the operation, this is defined by subtracting the first coordinate in each pair and then the second coordinate in each pair. Okay, fine. So it tells us this is equal to 1, 1. What's x, y? Very straightforward. First, let's work on 1, 2, and then that upside down triangle or upside down delta 6. This is going to be, by the definition we're given, it's going to equal 1 minus negative 3, comma 2 minus 6. That is going to say 4, comma negative 4. Now, that means that we know what this is, but we need to put it an upside down triangle with x, comma y. So I guess I'll do that in black. So we're saying that now this, which is 4, comma negative 4, needs to be put an upside down triangle with x, comma y, and needs to equal 1, 1. Okay? So that means 4 minus x, comma negative 4 minus y is what we'll have. And we need this to equal 1, 1. That means 4 minus x will have to equal 1, and negative 4 minus y will have to equal 1, from which we see that 4 minus 1 will have to equal x, and then negative 4 minus 1 will have to equal y. And so 3, comma negative 5 is what we're after. And that is an answer choice right there. Yeah? Okay, cool. So let's keep it moving, and 15 is next. 15 says cosine of t is equal to 5 over 6. What's the value of cosine 2t? Well, one way to do it is you could be like really nerdy and remember the cosine double angle formula, which I do. So you could be nerdy like me and then see that cosine 2t of three things is equal to 2 cosine squared t minus 1, right? And therefore you could write that this cosine 2t you're asked for is 2 times cosine of t is 5 over 6, so 5 over 6 squared minus 1, which is like 2 times 25 over 36 minus 1. You really don't have to do all this, but yeah, you can if you want. And it's not, I mean, we're not taking a lot of time, so this is very doable if you want to. So 25 over 18 minus 1 is 18 over 18. So that's, I believe, 7 over 18 if I do 25 minus 18 correctly. And so then you could type 7 divided by 18. And there you go. So that's 3.88. So, oh, sorry, 0.388. Right? I didn't lie, 0.388. Okay, I just misread it. Okay, so that's like that. The other way you could do it, obviously, is to do make sure, well, actually it doesn't matter if you're in degree mode or radian mode, but I was going to say make sure you check your mode. But you could do cosine inverse of, what is it, 5 over 6. This is going to give you what t is. So multiply this by 2, and you need, so now we've got 2t, and you need cosine of 2t, so you could just go cosine of, and by the way, a quick way to copy the last guy is to say second and then the negative sign right here, and it will be like answer, meaning your last answer. So there it is, and then we get to the same place, so we're all happy. All right. So what's next? Which of the following is a 0? Well, you know, there's this method called the AC method for factoring quadratics that don't start with a 1 in front of the x squared, but you don't have to know all that if you've got the TI-89. You could just, guess what I'm going to do? You could just, what am I going to say? Like, just use F2 solve and solve it. F2 solve, and then the quadratic is 2x squared, so 2x squared, and then it's minus 3x minus 1, and then well, we need to figure out it's 0, so equals 0, and then comma x, close parenthesis, hit enter. We should have 2 answers. Of the 2, what do they want? Well, only one of them appears, 1.78, so we're good, right? Okay, and there it is. And then this next question is kind of silly. It's saying what is the number of digits obtained by multiplying these two numbers? Let's just multiply them and we'll find out. So 1, 2, 1, 2, 1. This is just about typing them like carefully. And then times 3. Actually, you can make a mistake and still be fine as long as you don't like type the wrong number of digits in either of them. Now, now we hit enter, and it says like 4.338 e to the e10, meaning 4.338 times 10 to the 10th power. And so that 10 after the e is telling you how many digits follow that 4. Therefore, in total, there are 11 digits. Yeah, okay, cool. All right, so that's that on this one. And what's next? Well, I gotta do the back. So here it is. And the back is problem 18. So let's start with the first one. So by definition of the logarithm, we know that log base a of x is equal to y if and only if a to the y is equal to x, right? And therefore, from knowing this, we see that using this definition of the log, we can write what we're given as saying that log base x of 3 is equal to 9 if and only if a, which is x to the 9, so a to the y is equal to x, which in this case is 3. Like, you get it. So just show that this translates into that logarithmic form to exponential form. So we just have to do the same here. So we get x to the 9th equals 3, and so x is the 9th root of 3. So I guess if you like want me to write it, I'll write it. So that, right? And so in our calculator, what we're gonna say is 3 raised to the 1 divided by 9 power, and that's going to be 1.12, it looks like. 129, and so that's 1.13. All right, so that's B. Which of the following is a point at which the ellipse that intersects the x-axis? When we intersect the x-axis, y has to be 0. So if in the equation we make this y 0, the equation reduces to x squared over 5 is equal to 1. And then we multiply by 5 on both sides of this equation to find that x squared will have to equal 5, meaning x will have to equal plus or minus root 5. Now, I happen to know root 5 by heart, approximately. It's equal to 2.23, so plus or minus 2.23. And so that's A. Yeah? Okay, cool. Now, problem 20, a pretty cool problem. It says the function f is given by, so f of x is given by x minus this, which is defined here as the greatest integer less than or equal to x. So like, what would 1.7 be? It would be 1, because the greatest integer less than or equal to 1.7 is 1. And likewise for 1.99, right? So the greatest integer less or equal to 1.99 is also 1. And so if we're told that x will always be between 1 and 2 and equal to 1 but not equal to 2, we see that this is always going to reduce to 1. So f of x can also be given by, for these specific x's, it can be given by x minus 1. And so that is answer choice B. Yeah? Okay, cool. Okay, so we're done with this paper. And then next here, like if you know polar coordinates at all, if you've learned about polar coordinates, you'd immediately know that the answer is y, right? Because we know in polar coordinates that r sine theta is y if you've got a circle centered at the origin and radius r, right? Okay, and you've got xy as being a point on the circle. Well, if you didn't know that, then just by seeing the clue sine theta, you should know that you need to write a statement about sine theta. And if you write sine theta, you'd have to say that it's equal to the opposite over the hypotenuse. So that's going to be y over r. And then multiplying both sides of this equation by r, you immediately get that r sine theta is equal to y. So either way is a good way to get there. Now 22. So the remainder theorem says that if you divide by x plus 1, then the remainder will be plugging in the 0 of x plus 1 into the polynomial. So if you set x plus 1 equal to 0, you get x equals negative 1. So if you plug in this into the polynomial, then the value you get will be the remainder. This is always true in general. If you have p of x, a polynomial, divided by x minus a, then you first take x minus a and set it equal to 0, which gives you x equals a. And so p of a is going to be the remainder. P of a will be remainder. Yeah? Okay, cool. So we set x plus 1, which is x minus a negative 1, equal to 0 to get x equals negative 1, right? And then we plug it in, and so we haven't done that yet, so it'd be like 2 times negative 1 to the 4th minus 3 times negative 1. And this again is called the remainder theorem, minus a negative 1 plus 3. And so what is that going to say? Like, this is going to be 2, right? So I'll write up here, right? Because this is positive 1, so we've got 2. And then minus 3 times 1, so 2 minus 3. And then that's plus 1, right? And then we have plus 3. And what I'm going to do is I'm going to get rid of this negative 3 and that positive 3. So I'm going to get 2 plus 1, which says 3. And therefore, our final answer is 3. Yeah? Okay, cool. Now, 23. What I'll say about it is, like, a lot of things you know in 2 dimensions have a natural extension in 3 dimensions. Same is true for, like, for example, for the distance formula and the midpoint formula. Their 3-dimensional counterparts are very, very similar to their 2-dimensional counterparts. So here, the distance formula, a d in 3D is going to be this. It's going to be the square root of x1 minus x2 squared. And remember, you can do x2 minus x1 squared instead, because x2 minus x1 is the negative of x1 minus x2. As long as you square it, doesn't make a difference. Now, plus y2 minus y1 squared. And what we have to do is extend this a little bit and add to this z2 minus z1 squared. So you can label one of the points x1, y1, z1, the other x2, y2, z2, and like I said, doesn't matter which you label which. But yeah, if we subtract coordinates this way, then subtracting the coordinates of A from the coordinates of C, then we'd have the D is equal to square root of 2 minus 0 squared plus 3 minus 0 squared plus 0 minus 4 squared, which is going to be the square root of, what's that, 4 plus 9 plus 16, which is going to be, I know 9 and 16 make 25, plus 4 is going to be the square root of 29. We probably don't need a calculator, because if we look at the answers, it's not 5 and it's not 6, so it's got to be that in between, right? Okay, cool. There we are. Papers. Okay. And next is 24. That was 23, right? Don't want to skip any accidentally. So 24. Yeah. So there are fancier ways that you could do this without a calculator, but we're going to do it with a calculator because we're allowed a calculator. So we're going to do first arc sine of 0.9. And notice that 0.9 has to be an angle measure given in radians. So make sure that you change your mode. You go to mode and change if you're in degrees to radians. So this does say degrees, so we go to radians and select radians, and then we come home. And arc sine means same as sine inverse. So first we do that. So sine inverse of 0.9 is fine for 0.90. And now we could actually, we don't have to figure out the value first. We could just write cosine of that, cosine of our sine inverse of 0.9, and we'll have exactly what they're asking for. So we just have to get cosine now, and there it is. And so we close the parenthesis and hit enter, and there we are. So 0.44. All right, 0.44 is good by me. Okay, and next is like a little bit more drawing, right, of coordinate axes. So how did we do it? We did in black earlier, so let's stay consistent. So we need a small drawing, so why not? So let's say that's the x-axis, and let's say that this is the y-axis. Okay, so we've got, and you have the time to do this too on your test, even if you're doing it for real or the real test. Yeah, so this point is right here. Let's say root 2, right? And so like 1 is right there. Okay, and then the second point is at like 2, so not too far from root 2, at 2 comma root 10. So let's say 2 comma root 10 is right here. So this is 2 comma root 10. And then the third point is at 5 comma 0. So this is 5. Yeah, okay, so our triangle then is going to look something like, well, I made 2 like directly above 2 comma root 10, so ignore this, and let's say that 2 comma root 10 is actually right here, so that I could actually form a triangle that's not a right triangle look-alike. So our triangle is this, right? So we hope to find a height for our triangle. Our base is pretty easy to see as 5 minus root 2, right? So but our height is going to be drawn perpendicular to the x-axis, so like that, and our height clearly is root 10. Our base here is 5 minus root 2, so the area has got to be 1/2 times base, so 5 minus root 2 times root 10. Yeah, okay, and that's all stuff I'll type into the calculator, and yeah, so 0.5 I'll use for 1/2 times 5 minus 2 to the 0.5 power, and then times 10 to the 0.5 power. Notice that I'm letting the calculator figure out that putting just a parenthesis between each quantity means multiply them, and frequently we'll do that. Sometimes it will give you an error called invalid multiply, but yeah, that just means put a multiplication sign between your parentheses. Just a heads up. But what was this? This was 5.67. Okay, so that's answer choice B. All right, I think my calculator is a little bit dirty on the left corner, but you'll live. Okay, so let's move on to 26. 26 says x is equal to root t minus 1 and y is equal to t squared. What is y in terms of x? So if we went y equals a bunch of junk involving x, and the bridge is t. but we have root t here. So let's first get to t. So we start with the equation x equals root t minus 1, and we add 1 to both sides to get x plus 1 is equal to root t. And we square both sides of this equation to get that x plus 1 squared is equal to t. And now we know that y is equal to t squared. So y is equal to t squared implies y is equal to x plus 1 squared, which is t squared. And that's going to say y is equal to x plus 1 to the 4th power. And therefore, answer choice A. Yeah? Okay, cool. We're at halfway through the test. And so you should get to halfway through the test at a steady and fast pace, because like you're supposed to do the first half faster than the second half. Like, because the first half, they're arranged in order of difficulty. The first question is supposed to be the easiest, and the last question is supposed to be the hardest. So like basically you need to save time from working through the first half carefully, but efficiently. All right, what is the maximum value of f? It's clear that this function f of x is equal to negative x minus 1 squared plus 4 is another way to write it, and it's clear that it's in vertex form. It's also clear that it's a parabola that's facing down, and so a parabola facing down will have its maximum at the x-coordinate of the vertex, and the x-coordinate of the vertex is 1, so the maximum will be f of 1. And which is negative 1 minus 1 squared, so negative 0 plus 4, so it's going to be 4. And there's that. Now you could also graph it and look, and there are a bunch of other approaches, but this is a simple enough question that I'll not dwell on it. We're going to keep it moving. So yes, there are compound interest formulas, and really the only one that this Math 2 test frequently likes is the simple compound interest formula, which is like this, right? So an amount that you will have t years from now will be given by this formula, where r is the rate of gain or loss as given in the decimal version of the percentage. So 8% will have to be turned into 0.08 before you use this formula. But otherwise, p is a principal, and t, as I said, is years, and a is how much you'll have. So that's basically it for this question. So we see that a will be, in 6 years, we'll have an amount equal to our principal, 450, times 1 plus, our rate of growth is positive, it's growth, it's not decline, and it's this, and then t is 6, and so that says 450 times 1.08 to the 6th power, and here's where the calculator comes in. So 450 times 1.08 to the 6th power. Keep getting my calculator off center, is 714 and change, and so the best answer is 714. I dropped my black pen. So all right, there it is. Okay, so next is the first term in arithmetic sequence is 3. I like to start with writing the nth term in general, which is an, the nth term, is equal to a1, the first term, plus n minus 1 times d. This is true for an arithmetic sequence where d is the difference between any two consecutive terms. Okay, cool. So we know that a1 is equal to the first term is 3, so a1 is equal, and then a5 is equal to 17, and we're asked for a150 equals what, right? Got it. So first, let's use the information about a5 and a1 to figure out what d is, because that's sufficient. If you've got two terms of the sequence, you can always figure out, an arithmetic sequence or a geometric sequence, you'd always figure out the common difference and the common ratio in the geometric case just by knowing two terms. Yeah? Okay, anyway, so now we write 17 is equal to a1, which is 3, plus n for 5, which corresponds to 17. N is 5, right, for a5. So we've got 5 minus 1, which is 4, times d. So subtracting 3 from both sides of this equation, we see that we've got 14 is equal to 4d. And dividing by 4 on both sides, I'm ahead of myself, get that d is equal to 7 over 2. And that's where I had 2 in my head. Anyway, a150 is what you're after. So a150 should equal a1, so 3, plus 149, which is n minus 1, because in a150, 150 is n, and then times d, which is why we cared to find d, 7 halves. And now if you do all this, you should get an answer which I believe is 524.5. And we could do it like what is it, 149 times 7 over 2. I was trying to be lazy and save a little bit of time, but it's all right. Plus 3 is 124.5. Yeah, all right. So there is that, and we gotta do the back. So the back says